Good morning, students. I hope you all are in good health. So, we're going to start our next topic of chapter number 2, that is acids, bases, and salts. So, in the previous lecture, we have read about the different properties of acids and bases. So, moving ahead with the topic, today we're going to read about the diluting acids and the other things as well. So, diluting acids is a very simple and easy topic which I wanted to finish in the last lecture, but somehow I couldn't. So, we'll start with this today. So, diluting acid means simple. If we are having any concentrated acids and we gonna make a dilute form of those acids, so what we'll be doing in that? Simply, if I'm gonna ask you how you're gonna dilute the acids, so the answer will be that we gonna mix water in the acids. So assume if it is a beaker and it is having an acid in it, like it is having HCl in this beaker, and if we'll pour some water in this beaker which is filled with the concentrated acids, there will be a reaction which gonna take place very soon, like HCl plus H2O, and hydronium ion will be formed. Lots of hydronium ion will be formed along with chlorine. So because the sudden release of these hydronium ion, because HCl ion is having a lot of hydrogen ion in them, and as soon as we will be having H plus ion, and I've told you in the beginning of this chapter that either hydrogen ion or hydronium ions are formed. So the more the quantity of these hydrogen ions or hydronium ions, the more acidic the medium is. So since in the water the acids will dissociate into its ion, and there will be a lot of hydronium ion in the water which will create a lot of heat in the beaker, which will make the water to heat up very quickly, and it will comes to its boiling point, and due to that the water will splash out of the beaker and it can be harmful to us, like it can splash on our face. So instead of doing this, we're gonna have a beaker and we will add water in the beaker, and into it we will add the acids drop wise. We will pour the acid one by one drop, so that the hydronium ion and the hydrogen ion will be released, but they will be they will be released very slowly, so that the a lot of heat is not generated in one time, because that is an exothermic reaction. So that is the thing. Next, I'm gonna start with this. I will be taking the help of your book, since all of you will be having books, and I've reminded you all the time that you wanna read these activities, which are very important. Activities are important because a lot of questions are formed from these activities. So I would recommend to read all the activities and do all the questions, all the topics which are mentioned in your book, especially NCERT book. So since this activity we have discussed before also, but here I will be repeating again. So in this we will be taking two test tubes. So it is about basically that what happens actually when acids or bases are reacted in water solution. So we all know that whenever acids are dissolved in water, they just release their hydronium ion or hydrogen ion, and when the bases are dissolved in water, they release their hydroxide ion, that is OH negative ion. So if we will produce a dry acid, will they release their hydrogen ion? Because acids are called acids only when they releases their hydrogen ions. So in this we will have some NaCl, that is 1 gram of NaCl, and into it we will add some concentrated sulfuric acid, that is H2SO4. So here we're gonna close the mouth of this test tube with the help of a cork, and into it we will pierce a straw or a tube, so that the gas which is produced by mixing the sodium chloride and H2SO4, it will form a dry HCl gas which will come out from this tube. In front of this mouth of the test tube, we're gonna this delivery tube, we're gonna place a strip of a litmus paper that is blue in color. So we will see that no color is changed, because a dry HCl gas will not be able to release H plus ion. So if we will damp the litmus strip we will find that the litmus strip, which is blue in color, will be changing its color into red. This happens due to the release of H plus ion, because as soon as dry HCl gas mixes with the damp litmus paper, the water moisture or the water present in the litmus strip will react with the dry HCl gas, and the hydrogen ion will be formed, due to which it will be showing an acidic behavior and the color of the litmus strip will be changed. So this is about this activity. So next topic we want to study is how strong are the acids and bases are. To identify the strength of an acid or a base, we need to find out a table for that, and that is done with the help of a pH scale. Now pH means the term which is called as pH is just small p, it's written like this, and capital H. Okay, now pH defines that it is a potential of hydrogen. Okay, so potential of hydrogen means the strength of the hydrogen, because it is about hydrogen ion. Okay, so the number of hydrogen ion will be more, the strength of acid is more, and the number of hydrogen ion is less, the strength of acid is less. So in the pH scale, there is a scale ranging from 1 to 14. Okay, so like 1, 2, 3, 4, 5, 6, 7 is the center place, which is called as neutral, and then 8, 9, 10, 11, 12 and 13. So when we will move from 7 towards 14, that means it is basic or alkaline, and when we will move from this side to the decreasing order of the number 7 to 1, it will be more acidic. Okay, so I'm going to show you in your book also. Here, as you can see, 7 is the neutral. Moving towards the 14 number, it is basic nature increasing, and here the acidic nature increasing when we will move from 7 to 0 or 1. So what happens when the things are near the 7, like if we are having any compound having the pH value of 6 or 5, so it is near to the neutral, so it is lesser acidic, so we will call it a weak acid. Weak acid. And here from 7 to 9 or 10, this is called as a weak base. Okay, so now these are the weak acid, but here if we will move from 5 towards 1, it will be more acidic, and if we will move from 10 to 14, it will be more basic. So these things, acids are corrosive in nature and bases are caustic in nature. That means that if the things are more acidic, they're also very harmful to us, and if the things are more basic, they're also very harmful to us. So the human body or any plants or animals, even the nature, can survive when the pH value is around the neutral value. It is somehow, it is nearer, the range of the pH is near or close to the neutral value, that if the value is after 7, if it is 6 or 5 or 4, then it is okay, and if the value is 8, 9 or 10, then it is okay, but it is above 10, it is more basic, it is more alkaline, which is also caustic, and it is near the after the 3 or 2 or 1, it is more acidic, it is also very corrosive. So here you are having in your book a table which is a colorful. So here is the table in which there is a table or a chart which has different colors. This paper shows the different values of the pH. All these colors tells about the different pH value. Example, here is a table in which there are different solutions like saliva before meal and saliva after meal, lemon juice, colored aerated drinks, carrot juice, coffee, tomato juice, tap water, NaOH and HCl solutions. So we don't have any laboratory at home, but if when the schools reopens, we're gonna do this. So we will be having a strip of the universal indicator. When we will dip the strip of that indicator into this solution, the color will get changed, and when we will check the color, if the color comes of this shade, that means it's a pure thing, it is a neutral. And if the color changes to dark blue or dark purple, that means it's a lot of basic in nature. And if the color changes into deep red, that means it is very very acidic. If the color changes to slight yellow, that means it is a weak acid. And if the color changes to a dark green or slight bluish in shade, that means it's a weak base. So the water, pure water, is very very neutral. That is, the pH will be 7.4. It is neutral. And the value of blood also is neutral. So blood is neutral and water is also neutral. The pH is 7.4. So if we will test any baking soda, a solution of baking soda, or like antacids, it will be ranging of between 8 to 9, or something 9.4, just about that, not also towards the 10, because they are the weak bases, so we can consume them. But the metals which are very very highly reactive in the reactivity series, so those metals such as sodium and potassium, so the base formed out of those highly reactive metals are strong base. So they are of very very basic in nature, so they will have the pH value of 14. That is, they are very very caustic in nature. And the acids, that is HCl and the H2SO4, example, it's written gastric juice here, so they will be having pH of 1, because deep red color, they are very very acidic. So when we will move from left to this side, when the range will be decreased, the pH value will be less, and it will be more acidic, so that the hydrogen ion concentration will be high. The concentration of H plus ion will be high this side, and the concentration of H plus ion will be low this side. Okay, so the decreasing the value is, the higher is the hydrogen ion concentration. So this is all about the pH table. You can read this at your home, and if you have any problem, you can write whenever you do your homework, and even you can tell in the groups which we have made for you people. So next is the importance of pH in everyday life. So this pH value, that is potential of hydrogen, is very important in our daily life, as we all know that science plays a very important role in our daily life, and chemistry is everywhere. In everything the chemistry is involved, so the pH is also very important. The animals and plants are also pH sensitive, because whenever there is a lot of pollution, and when there is a lot of non-metallic oxide in the atmosphere, so when they are mixed with the water of the rainwater, and when the rain comes to the atmosphere, to the earth, so the soil there becomes acidic. It also loses the microorganisms. When those acidic water gets into the river, the aquatic life also get disturbed, and the animals have difficulty to survive. That means even the plants, the soil, the animals are pH sensitive. They all need a certain pH value to live. They cannot live in a higher or a lower pH value. They tends to live in the pH value which is around 7. So next is, what is the pH of the soil in your backyard? So here is an activity which you wanna read by yourself. In the activity, you will be checking the pH of your soil. So you would have seen farmers adding some white color thing into their soil. So what does it do? Due to the acid rain, the soil becomes acidic, or due to the use of lot of fertilizers, the soil become acidic. So to make the soil mild and neutral, they add some calcium hydroxide into the soil, so that, because calcium hydroxide is a base, so the base will neutralizes the acid nature, because it will undergo the neutralization reaction, and when acids and base combines, they form salts. So the addition of base will help in the decreasing the acidic property of the soil, and which will help in maintaining the pH balance, the pH value of the soil. pH in our digestive system. So now we all know that in our stomach there is the gastric juices will help to digest food, which kills the bacteria, that is HCl. So when the quantity of this HCl is increased, when we have a lot of acidic food, when we have a lot of things which are acidic in nature, so sometimes we get burning sensation in our stomach and indigestion, which causes pain and irritation. So to get rid of all this, we use some antacids. So antacids are the bases actually which are antacids, so we call them antacids. So these bases are such as magnesium hydroxide, which is also called as milk of magnesia. So this milk of magnesia is taken by the people who are having acidity, and it will undergo the neutralization reaction into our stomach because it is a mild base, so it is used to neutralize the acidity of our stomach. So next is pH changes, or it causes the tooth decay. So the food whatever we eat, when it in our mouth, the digestion takes place. So due to our saliva, the food just get disintegrated, and it is sometimes it increases the pH level of our mouth. So when it becomes less than 5.5, it is more acidic. So because of the production of a lot of acid in our mouth, the teeth, which are made up of because the enamel of the teeth is made up of the salt which is called as calcium phosphate, and calcium phosphate will get corrode because of the presence of a lot of acid in our mouth, which will produce a cavity in our teeth, and they will also cause some foul smell. So the best is to clean our mouth, to rinse our mouth after we have our food, so there are no hidden particles of our food in our mouth. We use this toothpaste because they are made up of salts which are basic salts, so those salts also help to neutralize the excess of acid in our mouth, which also prevents in the tooth decay. Next is self-defense by animals and plants through the chemical warfare. You would have seen many insects such as bees and ants. They just sting on your body, on any, because they need protection, so they use these stings. Their stings contain formic acids and methanoic acid, due to which we have a very painful sensation in our body whenever they sting. Also a plant called nettle leaf, which is called as bichu ghas in our vernacular language. So whenever we get touched into that plant, we also have a sting kind of a feeling which causes pain and irritation. All that happens because of the release of acid. So to get rid of that pain, we use some base on that portion. You would have seen your parents rubbing the calcium, that tuna thing which we call as calcium hydroxide onto that portion, because when there is an acid and we will react it with base, it will neutralize, forming a salt which will be called as a neutralization reaction. So that is why we use bases when we get sting with any insects and any plant like this. So please go through your book. I hope you all have your books. Here are some these table which are having some natural sources and the acid which they have. Please read this, because many times I have seen questions coming that which acid is present in ant sting, and students almost every time do the mistake. So please read all these things. That is, a methanoic acid is present in the ant sting. Also in the nettle leaf, it is also a methanoic acid. So this completes your today's this lecture. In the next lecture, I will be teaching you about these salts, which is very important, and what are the things which are formed from those salts. So we're gonna start our next lecture. Till then, please try to do your all the question answers, and all the problems you are having, tell us so that we can solve those problems. And study hard and stay safe. Thank you.